Hello crafters, welcome back to Code Crafters. In today's video, we are going to explore the most important aspect of C++, object-oriented programming. So, let's get started. Object-oriented programming is a programming paradigm that organizes code into objects, which are instances of classes. A class serves as a blueprint that defines the attributes, data, and methods, functions, associated with an object. By structuring code into objects, object-oriented programming provides a logical way to design software that mirrors real-world entities, making it easier to manage and extend. This approach promotes modularity, where different parts of a system can be developed and modified independently, leading to cleaner and more maintainable code. At the core of object-oriented programming lies the concept of encapsulation, which restricts direct access to an object's data. This ensures that internal details of an object are hidden from external interference, maintaining data integrity and security. Instead of directly modifying object attributes, encapsulation enforces controlled access through getter and setter methods, preventing accidental modifications. This not only safeguards sensitive data but also improves code flexibility, allowing changes to be made without affecting other parts of the system. Another fundamental principle of object-oriented programming is inheritance, which allows one class, child, to reuse the properties and behaviors of another class, parent. This reduces redundancy by enabling developers to define common functionality in a base class, which can then be extended by multiple subclasses. For example, in a system where different types of vehicles share common features like speed and fuel consumption, a base class vehicle can be created, and specific classes like car and bike can inherit from it. This promotes code reusability, making software easier to maintain and scale. Polymorphism enhances flexibility by allowing methods to take different forms. This means a single method name can have multiple implementations, depending on the object that invokes it. Polymorphism can be achieved through method overriding, where a subclass provides a specific implementation of a method already defined in the parent class, or method overloading, where multiple methods with the same name accept different parameters. This enables developers to write generic code that can work with different object types, improving adaptability and reducing code duplication. Lastly, abstraction is the principle of hiding complex implementation details and exposing only the necessary functionalities. It allows users to interact with objects without needing to understand their internal workings. For example, a bank account class can provide methods like deposit and withdraw, while keeping the underlying transaction processing hidden. This simplifies the interface for users and ensures that only relevant details are exposed. By focusing on essential features, abstraction reduces complexity, making systems easier to use and maintain. By combining encapsulation, inheritance, polymorphism, and abstraction, object-oriented programming provides a structured, reusable, and scalable approach to software development. These principles work together to enhance code organization, security, and efficiency, making object-oriented programming a powerful paradigm for building robust applications. Let's have a look on the comparison of object-oriented programming and procedural programming. Procedural programming follows a linear, step-by-step approach where code is written as a sequence of functions operating on data. In contrast, object-oriented programming structures programs around objects, making them more modular and reusable. While procedural programming is efficient for small projects, it can become difficult to manage as code bases grow. Object-oriented programming, by organizing related data and behavior within classes, allows for better scalability and code maintainability. For example, in a banking application, procedural programming may involve writing multiple functions for transactions, whereas object-oriented programming models accounts as objects with built-in methods for deposits and withdrawals. Let's discuss why object-oriented programming is used. Code reusability and modularity. Object-oriented programming promotes code reusability and modularity through inheritance, a mechanism where a new class, subclass, can inherit properties and behaviors from an existing class, superclass. This eliminates the need to rewrite code for similar functionalities, reducing redundancy and making the program more efficient. By reusing existing code, developers can build applications faster and maintain consistency across different parts of the system. Additionally, modularity ensures that different components of a program can be developed, tested, and modified independently, making the overall system more manageable and scalable. Maintainability and scalability. The encapsulation principle in object-oriented programming helps in maintaining and scaling software efficiently by restricting direct access to an object's data. Encapsulation allows data to be bundled together with the methods that operate on it, preventing unauthorized modifications. By keeping data hidden and only accessible through well-defined interfaces, such as getter and setter methods, encapsulation reduces the risk of accidental changes and bugs. This makes the code base more maintainable, as developers can update or extend functionality without breaking existing implementations. Additionally, scalability is improved because objects and classes can be extended or modified without affecting other parts of the system. Data security and integrity. Object-oriented programming enhances data security and integrity by allowing controlled access to class members through private and protected access modifiers. Instead of exposing data fields directly, object-oriented programming uses getter and setter methods, which enforce validation rules before modifying an object's state. This prevents unauthorized access and unintended modifications, ensuring data integrity. Encapsulation also protects sensitive data from being altered by external code, reducing the risk of security vulnerabilities. By structuring programs in a way that limits access to crucial information, object-oriented programming helps in developing secure and robust software applications. Polymorphism and flexibility. Polymorphism is one of the core principles of object-oriented programming, allowing objects of different classes to be treated as instances of a common superclass. This feature provides flexibility by enabling a single function or method to work with different types of objects. For example, a method in a parent class can be overridden in child classes to provide specific implementations while maintaining a consistent interface. Polymorphism enhances code maintainability, as new functionalities can be added with minimal changes to existing code. It also improves flexibility by enabling dynamic behavior, where objects can change their functionalities at runtime, making the system adaptable to varying requirements. Thank you for watching, and happy coding.